What's up, Calc gang? All right, we got this differential equation here. It wants us to find the specific solution, the particular solution or whatever. Looking at it, it's homogeneous, and what's great is we can solve it with a cool technique. So let's get started. Okay, so what are we gonna do here? Well, we're gonna use the fact, we're gonna just go ahead and say this, y is equal to e to the rt. And this is gonna allow us to do a whole lot of things. So let's get started. So of course we can take the second derivative, and that's gonna be r e to the rt. And then y prime, it's going to be r squared e to the rt. Okay, so if we do this, we can plug these into this value here, or this equation here, and we can move on. Okay, so it'll be r squared e to the rt plus 4r e to the rt, and then plus 3 e to the rt is equal to 0. Okay, and then here we can go ahead and factor out that e to the rt. And then it'll be r squared plus 4r plus 3 is equal to 0. And then what we're trying to find here is some values of r that we can use later. Okay, so looking at this, what is our values of r going to be to make this equation true? So this e to the rt, this will never be 0, so we cannot worry about this for now. Just looking inside here, this is our, I think it's our critical equation is what it's called. Is it a critical? I don't know. It's something like that. So of course we can factor this. So let's go ahead and look at it. This is going to be, so let's look at this. So it's 3 and 1, so it's probably, yeah, r plus 3, r plus 1. This is like, I hope I don't have to explain this. I definitely don't. Okay, make sure I'm doing the question right, yep. Okay, so r is equal to -3, r1 is equal to -3, r2 is equal to -1. So with these two values, we can go ahead and say something cool now. So we can say y of t, this is our function finally, so it's going to be constant 1, e, and then to the rt, but it's going to be r1, so -3t, plus c2, e to the -1t. Now this is our general solution right here. Using this format, where you do c1, e to the, with the rt's. Okay, so now we have to find a particular solution. So we have two initial conditions, which is going to help us solve this problem, because we have two constants, so we're going to need it for that. Okay, so let's go over here and take the derivative. So y prime of t is equal to, so the -3 is going to come down, c1 e to -3t, and then that negative is going to come down, so it's going to be -c2 e to the -t. Okay, so let's go ahead and plug in our initial conditions for these. So y prime of 0 is equal to -1, and if you plug in 0 to all this, you're going to get -3c1 minus c2. Okay, so you can't solve this yet, so let's go over and look at this one. So y of 0 is equal to 2, so then you plug in 0 for all this, you're going to get c1 plus c2. Okay, now we have to look at how are we going to get rid of this, how are we going to get rid of one of these? And the way I like to do it is I like to add the equations. So I guess I'll go over here. So we're going to take this and just write it out. 2 is equal to c1 plus c2. And then we're going to add that underneath. So -1 is equal to -3c1 minus c2. And then literally all we have to do is add these together. So 1 minus 2, or 2 minus 1 is 1. -2c1. And then these are going to cancel out. And then of course, look at this. We got something nice we can work with. So it'll be -1/2 is equal to c1. And simply plug that in over here. So it'll be 2 is equal to -1/2 plus c2. So that means that c2 is equal to 5/2. Okay, I'm going to erase some of this. Get my particular solution right over here. Okay, so simply all we have to do is plug in those constants. Hope I'm not going too fast or anything. Okay, so constant 1 is 1/2, or -1/2. And then plug it into our, did I erase my general solution? Oh, I did, didn't I? Hold up, oh, it's right, it was right here. You can see it still. Wow, I can't believe I did that. Okay, so you're going to plug the constants into that. So e to the -3t, and then it's going to be plus 5/2 e to the -t. And there you go, that's our general solution, or particular solution. All right, so the next part of this problem wants us to graph it and determine its behavior as it approaches infinity and negative infinity. All right, so we're going to look at this. This is t, this is y. All right, so let's see what happens. So as it approaches infinity, let's do that first. As it approaches infinity, these t's are going to get really big, and basically that means that we're going to get really small. But which one's going to get smaller quicker? This one or this one? So we're looking at it as we approach infinity. This number is basically always going to be way smaller than this number, which means that because this negative 3t, if you take 10 and then you multiply it by negative 3, it'll be negative 30 as compared to negative 10. So this number is basically the smaller number. It means it's going to not control, which means that this is the dominant factor as we approach infinity. So then we just have to look at this. What's going to happen is as t approaches infinity of this, it's going to approach 0 from the positive side because we have positive. So you can see that it's going to kind of go, something like that. All right, let's look at 0. When we're at y is 0, we're going to be at 2. So here's 2. And then our slope is going to be negative 1, like that. Okay, so let's look at negative infinity. So at negative infinity, we can see that as we approach negative infinity, what's just going to happen? This is going to be an infinitely large number, and this is going to be an infinitely large number. But this one is going to be even bigger because that's that 3 in front of it. You see what I mean? The negative 3 times the negative number that it multiplies by is going to make it a very large exponent, which means this is the dominant factor as we go to negative infinity. And when we look at this, we see that it's going to go to, if it was, it would approach infinity, but it has this negative 1/2 in front of it, meaning it's going to approach negative infinity. So we're going to go down kind of approaching it negative infinity like this. So now all we have to do is connect the dots. It goes like this, up through here, and then down, approaches negative infinity. So there you go, that's our graph. I'm going to double check that. Hold up. Oh, I'm doing the wrong problem, haven't I? Yeah, okay. Panicked a little bit. Yes. Yeah, okay, I'm pretty sure this is right. Yeah, okay, I clicked the wrong problem. But yeah, this is how you do this kind of problems, guys. Good luck on your differential equations homework.